that people are now sort of working on being able to do simulations of things like chemical reactions, which could potentially have some kind of industrial impact. So I think, the sort of accessible simulations are likely to be the first ones which have some sort of value added, if you like, and some beneficiaries. But beyond that, it's very difficult to say, I think, and the people who are best placed to answer it are probably the people who are developing the algorithms and that side of things.
Okay, thank you, Jason. And Rob, you have the honor of giving an answer to what I agree was perhaps the hardest question of the lot I left to the end.
It was the hardest question, and indeed I agree with Barry that there's this problem with confounding quantum computing and quantum technology is one we need to sort of work on improving. But I mean, I will actually sort of comment or try and comment on quantum computing, because I think that there's maybe two things that I find interesting. And one of the things that where it's impacted, and I think generally what, let's say in a reasonable time frame in the near future, the impact is going to be more still scientific research. And I think which has your obviously the potential to translate into products and things that industry and governments will use. But already the one I find the most interesting is classical computing software, which has been and algorithms which have improved markedly by people thinking differently about how to beat quantum algorithms. So I think this is something that's already started to take place, and I think it's sort of an unintended consequence. But then I think after that, more let's say focused on quantum computing, I think in the next few years these NISQ, noisy intermediate scale quantum devices are going to start to make some interesting insights into just niche applications, but things that are really going to start to show a definite quantum advantage. And once we have those sorts of things, we can start to build applications that fit for real world use.
Rob, thank you very much. And that really does bring us up to the hour. So I'd now like to just thank the entire panel. So that's Jason Smith, Rob Thew, Barry Sanders, Barry Garraway, and Mateen Durrani for what I feel, and I hope the audience agrees, was a really diverse discussion. We touched on many issues, many points, many subject areas. And thank you once again for your informative, really compelling views on a wide range of issues. I would just like to close with a couple of adverts actually for other IOP presentations that are going on at Quantum 2020. Specifically 2 talks that are taking place this week. So tomorrow, Tuesday the 20th of October at 7:30 p.m. Beijing time, we have one of our ebook authors, Frank Duarte, talking about a forthcoming book that will come out in 2021, actually, Quantum Entanglement, Engineering and Application. So if you can, please seek that talk out. That's 31253. And then on Wednesday, my colleague, Tom Sharp, publisher for Materials for Quantum Technology, will be giving one of our IOP Publishing Academy presentations, where he'll touch on the peer review process and some really great tips for what it takes to get published in highly selective journals like Materials for Quantum Technology. And then in terms of our posters, you can actually find posters for all of the products that have been presented on the panel today. 31299 for Quantum Science and Technology, 31293 New Journal of Physics, 31294 Materials for Quantum Technology, 31298 ebooks. And then I really encourage you to seek out a poster from Kim Eggleton, our Research Integrity and Inclusion Manager, which will touch on some of the diversity points we raised in the session, specifically around evolving peer review and what that means in terms of diversity, training, and transparency. And with that, I would like to thank you all for tuning in for this session. I hope you found it of interest, and do enjoy the rest of Quantum 2020. Thank you.